All right, students, welcome to Lesson 3, Unit 3. You should be on page 221. So, I am going to walk you through this lesson. Your job is to follow along and write everything down, but also kind of pay attention to the workflow and listen in carefully, because I'm going to explain a lot, but might not necessarily write a lot on the board. There's already some information on here, so while I'm talking, you are welcome to go ahead and start writing this down. But basically, in this lesson, it culminates with us finally graphing and using. We've already built those skills throughout the last few days, how to look at different types of scales, how to use proportional relationships, and create the equations. Well, we're going to use all of the representations and add tabling today. Okay? So with that being said, I'm going to read this situation. Please make sure you catch up and write what you see on the board. Feel free to pause the video at any point. So here we go. We got Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, Jada took 8 steps while Noah took 10 steps. Then they found out that when Noah took 15 steps, Jada took 12 steps. We're given the story problem. We're also given an equation, but look at this fancy equation. It said let x represent the number of steps Jada takes and let y represent the number of steps Noah takes. So they kind of give us what x and y are going to stand for. Jada's x, Noah's y, so that takes a little bit of thinking out. But the equation is in a different format than we've been using. We have typically used this format, y over x equals 5 over 4. And if you look carefully, all we've really done is taken the x and moved it to the other side. Algebraically, that is possible. So this is our new equation format. We're simplifying it just a little bit more. This is called a proportional relationship equation. In the format is called y equals kx. So throughout this week, I told you, one of our target goals is to understand what the constant of proportionality is. Well, k is the constant of proportionality. So what I'm saying here is that the number in front of the x, if we use this format, y equals kx, is called the constant proportionality, and you already know it. Even though it's a fancy word, you actually already know it. So I'm going to put a big old or. It's actually the slope. It's the slope if 0, 0 is on the line. So that magic 0, 0 can be our second point when we calculate slope. Well, the constant of proportionality is the slope of a special line that always goes through 0, 0. So that's really how we start our journey down studying linear equations. So this is going to be our new format, y equals 5/4 x in this case, and k, the number in front of the x, is our slope or constant of proportionality. So as we're working through this, okay, keep in mind to start working on using that type of equation, creating that type of equation. It's very much the same as what we did with y over x equals 5/4. We're just moving that x to the other side. So a couple things to think about. In this case, they already gave it to us. What is x and what is y? Sometimes they don't. We're going to have to be kind of smart about what we want to label as our x variable and our y variable. But in this case, Jada's x and Noah's y. So it says in part A, let's create a table that represents this situation with at least 3 pairs of values. Well, in the story problem, they gave us Jada's 8 and Noah's 10 steps and 12 and 15. So I put those in. And don't forget the magic 0, 0. We're going to put those in. Technically, we already have 3. But what I want to do is make sure you know we can use the equation to find more. We're going to add a couple more. Doesn't mean we're going to plot them all, but we're going to add a couple more. So if I'm looking at this equation, this one's a little bit tougher to figure out combinations of x and y because we got that 5/4 slope. So my recommendation is to pick good points that are scaled similar to what we have. Like Jada has 8, 12, 0. Noah has 10, 15, 0. If you notice carefully, Jada is all multiples of 4 and Noah is all multiples of 5. So my recommendation is to use x as our starting point, and let's pick numbers that are multiples of 4. So if I say Jada took 16 steps, I'm going to pop that in the calculator. Have a calculator, please, if you haven't. Then I would punch that in the calculator. Noah would take 20 steps. It gives us nice round numbers if we start looking at some of those patterns. You can arbitrarily just pick one step, two step, three steps, but you're going to find that some of those numbers are going to be a little bit more decimal, and that's fine. It still works. Let's pick something like 20. If Jada takes 20 steps, that means Noah is going to take 25 steps. And just to prove a point with any kind of input that we put in, any kind of X, if I just pick 2, say Jada took 2 steps, Noah, if I pop that in the calculator, would take 2.5 steps. Perfectly fine, just not a pretty looking number. But as we're working through this, we're just tabling by finding appropriate X values. Now, we talked a whole lot about scale yesterday when we were doing the card sort. Look at the numbers I chose. If you're picking numbers like 1,000 or 522, those are obnoxious numbers that don't work with this scale or the type of numbers that we got. So that's our first skill, finding appropriate numbers to fill out a table. So at this point, pause the video if you need to catch up. We're going to use these numbers, and then I'm going to scroll here in about 5 seconds on the video. All right, so if you flip the page to 222, we're going to go ahead and actually graph this. So there are a couple things that we need to think about when graphing this. First, we have to think about our scale. And secondly, we have to think about labeling the axes. These are kind of common, typical instructions you'll see. So on this graph, I'm going to actually go ahead and copy the table up here so I don't have to keep referring back to it. But on this graph, you notice they give it to us, so typically when they give it to us, we got to be extra careful of our scale. We got to use the space that they give us. Okay, so let me go ahead and zoom in on this. Here we go. All right, let's label the axes first. So we had Jada at the bottom. We're going to put Jada's steps, because that's technically what the units are. And on the side, we have Noah's steps. Okay. Label them first, and then for the scale, we kind of want the big things to think about with scale. Okay, so I'm going to put a little pointers about. Okay, fill the graph. You don't want to just go ahead and use a small portion of the graph, so I'm going to highlight it here. Typically, what I often see is students will use a scale, and it might not be big enough where it just fills a small corner. Whatever graph they give you, we want to use the entire space. Additionally, when we are using a scale, pick common types of scales. Pick common scales. You're going to notice that just going by ones is not going to be our best scale all the time. We can pick scales like going by 2s, going by 5s, going by anything that will fit the shape of the graph and fill out the space. Okay? And also the third pointer for scale. X and Y can be different. It often will be different. So that allows us to go ahead and fit the space just as well. So if you are looking at this, I have a lot of lines on the X, a lot of lines on the Y. My Jada values go up to 20 and as low as 2. So those numbers look pretty well for us to use 2s. So if I go by 2s, that will probably fill up this graph pretty well. So I'm labeling it right now, and you can do that too. So if I go by 2s, and by the way, when we scale it, we're actually putting the numbers on the grid lines. So if it makes it a little bit easier, you can kind of see what I'm doing here with the hash marks, tick marks on the x-axis. So we're labeling it on the lines. Don't forget that lovely 0 at the beginning. And then if we look at the y values, all right, they're about the same type of numbers. The lowest number is 2.5, and it goes all the way up to 25. So I'm going to go ahead and use 2s again. So it's not always going to be the same scale on both sides, but it's not a bad thing if it is. So for this starting example, going by 2s is going to be appropriate. And then from here, if you're ahead of the game, just start plotting. The point is, we're going to plot those points and make sure that they are appropriately shown on the graph. Now, a couple little pointers here. When you are graphing, depending on the scale, notice that I have something like 2.5. I have things, okay, they're not exactly going to be on the grid marks or where they intersect. And the best thing that I'm going to mention on making a graph look accurate is an accurate graph only needs 2 points. You always have 0, 0. So if I plot something like 8, 10, which I did just now, that is 100% an accurate graph. I connect those two lines, 2 dots to create the line. But as you're working through this, if I plot 12, 15, it's right there, and 15 is not bad. It is right there halfway between the grid marks, but sometimes your line might not exactly go through it depending on the scale you use. But if you can find 2 points that are 100% accurate, cross the grid marks, your line is accurate. So take a moment to go ahead and plot all the points that I have here just to go ahead and get that practice, and that should complete most of this activity. Okay. So I'm going to do the same, and away we go. Okay, so at this point, pause the video if needed. Okay, what you should have is an accurate looking graph that looks very similar to mine. Notice how well it fills the graph, shows all the data, and I can read the data if I need to. So pause the video if needed. I'm going to let it go for about 5 seconds before we move on to the next activity. All right, students, at this time, that concludes the directed part of this lesson. Your teacher is going to pass out the cool down. Now, when you get the cool down, notice you're going to be sketching a graph. It says that the relationship between grams of honey and grams of salt are needed for a bakery recipe and shown on this table. Show on the graph how much money is needed for 70 grams of salt. So you're going to have to graph this. But notice they gave you a point already. They gave you 70. So there's a couple things that you're going to have to think about as you walk through this cool down. Okay, so I'm going to add this to the side. So one of the things is create an equation. So you have points. You have points here. And you actually have extra information. It says grams of honey and grams of salt. Okay, so we don't need the flour information. So you're going to have to create an equation. Now, don't forget, when we create an equation, we are using that y over x equals the slope. You have to somehow figure out the slope. Though once you have done that, the equation we're transitioning to is y equals kx. You're just moving the x over to the other side, and k is going to be the slope. So one of the things that you're going to have to also know in order to create this equation, because these are, it's difficult because you don't have a graph, but we have talked constantly about how if we use 0, 0, we can find the slope by looking carefully at how we can find the vertical height and the horizontal height. So to kind of help guide you on this cool down, let's use salt as x and let's use honey as y. So if I'm graphing, I'm going to label it right now, and that gives you some information here. So there's quite a few ways you can approach this, but the goal is somehow you got to show on the graph 70 grams of salt. So in this case, you need to have a scale that will properly show it, okay? And you need to fill up that graph appropriately. Once you're done with the cool down, turn it into the front table. Then work on problem 1 and 2 on page 227. It's the practice problems. Those, the cool down I will personally check, and we will be looking that over for the coolest cool down on the next lesson day. But for the classwork, it's problem 1 and 2 practice pages. You do not have homework tonight, so once you finish those practice problems, you can use the rest of the time on your own to work on something efficiently. So with that being said, if everyone understands instructions, this concludes this lesson video. Thank you.